Convair, Fort Worth, the Air Force has established one of its first facilities for research and development of a nuclear-powered aircraft. The program began at Fort Worth in 1951, and now the first airborne operation of the low-energy nuclear reactor has been achieved. This is the reactor operations area where the ground test reactor and the aircraft shield test reactor are tested and maintained on the ground. The aircraft shield test reactor shown here was designed and built by Convair to study shielding and radiation problems. This heterogeneous reactor uses light water as its moderator, coolant, and reflector, and has a 1 megawatt power rating. A unique feature of this reactor is its flexible shield system. The forward section is a removable tank consisting of water compartments and lead shadow discs. A series of water tanks surround the reactor core, and 2 water shields cover the aft end. All the water tanks can be filled or drained in flight to vary the shielding. When maintenance is completed in the handling pool, the aircraft shield test reactor is moved to a loading pit by a large crane. The crane is operated from a shielded cab and has a remotely controlled self-centering hook. Before the test airplane arrives, the reactor is lowered into the pit. Convair uses a modified B-36H as a vehicle for airborne tests. This stripped-down airplane has a new nose section to house the shielded crew compartment and has a special capsule in the bomb bay to control instrument environment. A cooling system located in the aft fuselage dissipates reactor heat. The modified aft bomb bay area has a special mount and water and electrical disconnect systems for remotely installing the reactor. A lead shadow shield, 5 inches thick and weighing 5 tons, is mounted in the forward end of the reactor bay to give added shielding for the flight crew. For reactor loading, the test airplane is towed to the operations area. Here, with the aid of turntables, it is positioned over the loading pit. The loading operation, which takes approximately 20 minutes, is handled remotely from a shielded control room beside the pit. As the 7-inch thick pit covers open, the reactor loading operation begins. The reactor is aligned with the airplane using probes which measure alignment of the 4 platforms on the hydraulic lift. These platforms control fore and aft, side to side, and pitch and yaw motion. With loading finished, the engines are started and the airplane moves out for takeoff. For normal data flights, the nuclear test aircraft takes off at a gross weight of 357,000 pounds. After the nuclear test aircraft and its escort, a B-50, arrive at the test corridor, which is well removed from populated areas, preparations are made to start reactor operation. The reactor is started by withdrawal of the safety rod, the dynamic control rod, and the shim safety rod. Various conditions of hot flight operation are monitored and adjusted by the nuclear engineer. When the desired power conditions are reached, the reactor power is stabilized and the recording of nuclear shielding data begins. Radiation levels are measured by the flight test engineer in the cabin as well as throughout the airplane fuselage during reactor operation. Flux patterns of air-scattered radiation around the nuclear test aircraft are obtained by special instruments in the B-50 escort plane. Upon completion of the data runs, the reactor is shut down in preparation for the return flight. With the reactor shut down, the nuclear test aircraft and its escort return to base. These first airborne reactor tests at Convair, Fort Worth, are supplying valuable information. Information which will provide guidelines in shielding, effects of radiation on aircraft systems, airborne nuclear instrumentation, and ground support techniques. Such information is vital to the design of the Air Force's first nuclear-powered aircraft.